All right, guys, section 1.5 is on solving inequalities. So we've been talking about solving equations, and equations are where we have one answer, right? And inequality, you learned this term in sixth grade, maybe fifth grade, okay? These have multiple answers. So usually you might remember inequalities are less than or equal to, greater than or equal to, okay? So just a few vocab words, like I said. Yes, vocab is extremely important in algebra and the corresponding inequality signs to begin this section. Remember, just because we're not in language arts or social studies or science, vocab is huge in math. So, symbol for less than, just like that. More than, all right, is greater than. Up to. So if I say you can have up to 20 kids in your class, you're not going to have 20, you're going to have less than 20, right? At most will be less than or equal to. At least means I can have at least 20 kids in my class. That's going to be greater than or equal to. In between, all right, greater than is also that. Between, all right. Basically, if I have a variable, let's say x, I'm going to have two arrows next to that variable. Okay, that's between. So you're going to start seeing this idea of between down below, which we're going to get into. So it says solving inequalities, graphing of solutions, and interval notation, another new vocab word. We're going to go over it here in a minute. So first steps when you graph these, all right, is do exactly what we've been doing. I want to get a variable by itself, so I'm going to add 5 to both sides. So I get x is less than or equal to 15. Now, here's my number line. If I have 0 and 15, I know x is going to have to be less than or equal to that. So in sixth grade, you guys learned about this idea of drawing a circle, okay, shaded versus opened. Anything with the line underneath it, so less than or equal to or greater than or equal to, will be a shaded in circle, okay? And I always remember less than or equal to, so anything less than 15 or equal to 15 will make this statement true. So if I said 15 minus 5, well, 15 minus 5 is 10. Is 10 less than or equal to 10? Yes. Let's pick another number, 0. If I do 0 minus 5, that's negative 5. Is negative 5 less than or equal to 10? Yes. So I know that that is a true statement. Interval notation is from left to right, meaning, hey, what are different solutions? What are different answers to this equation? So all the way to the left, okay, this bracket, sorry, we're going to do parentheses. Parentheses all the way to the left, meaning anything over here to the left of 15. So negative infinity, anything to negative infinity will make this statement true. Negative 100 would be a number over here to the left, right? Negative 100 minus 5 is negative 105. Is negative 105 less than or equal to 10? Yes. So any number less than any number less than 15 will make that true. So anything from negative infinity to 15, and I'm going to do this bracket because it includes 15, all right, which we're going to discuss tomorrow in class, all the way up to 15 could be a solution. So parentheses means it gets close to, and a bracket means it hits. So from low to high. All right, let's try this next one. Hear me out. Let's first of all graph, and then we'll do interval notation. So I'm going to subtract 2x on both sides. Subtract 2x. I'm left with x plus 4 is greater than 1. Now subtract your 4 on both sides. I get x is greater than negative 3. So let's graph. 0, negative 3. Draw your circle. Will it be opened or closed? Well, since it's greater than, it's an open circle, right? It's going to be greater than negative 3. They're saying anything greater than negative 3 will be a solution. So let's pick a number. Let's just say 0 because 0 is greater than negative 3. 3 times 0 is 0. 0 plus 4 is 4. Is 4 greater than? Well, 2 times 0 is 0 plus 1. Is 4 greater than 1? Yes, so that works. Interval notation from left to right. Now, notice how I do this parentheses because from left to right, the smallest the number can be is super close to negative 3. I didn't hit negative 3 because negative 3 would not make this statement true. Hear me out. 3 times negative 3 would give me negative 9. Negative 9 plus 4 is negative 5, right? So I'll just jot that down. they're saying if -3 is a solution, 2 times 3 is -6. -6 plus 1 is -5. Is -5 greater than -5? No, it's equal to it. So by putting these parentheses here, I'm saying, hey, anything super close to -3, any of these numbers from -3 all the way to positive infinity will work. Now you can't hit positive infinity, right? It just goes on forever. So I'm going to use parentheses. Now say it hit at 10, which we're going to go over some examples of that here in a little bit. That is when you would use the bracket, all right? But parentheses means it gets super close to. You can't hit infinity, so that's why we use parentheses. This next one, let's do it together. I'm going to add 12 both sides. Add 12 both sides. I get 20 is greater than or equal to x. Now, I always like to have my variable first. So I can flip it because of the commutative property. If I flip my variable first, meaning x first, I also have to flip the sign to go the other way. So that means x has to be less than or equal to 20. So if I write this down, I have, let's just say this is 0. Here's my 20. Here's my -20. X has to be less than or equal to, which means my circle is closed, 20. So anything to the left of 20 would make this statement true. So I have 8 is greater than or equal to, let's just put 20 in. 20 minus 12 is 8. Is 8 greater than or equal to 8? Yes, so that works. We're going to be talking about how to verify and show your work here later this week. Let's just say 0. Easy. Is 8 greater than or equal to -12? Yes. So anything from 20 to negative infinity would work, right? So interval notation, left to right, negative infinity all the way to 20. Notice how 20 is an answer because of that little bar there. So bracket it, okay? I'm going to have you guys try 4 and 5 on your own. So you're going to graph and do interval notation, okay? And I'm going to hop in down here on 6. 6, you might remember to get a variable by itself, we have to multiply by the reciprocal. So the reciprocal of 2/3 will be 3 halves times 3 halves. When I do that, those clear, I'm left with x is less than or equal to 8 times 3 is 24. 24 divided by 2 is 12. Okay, another way to look at that is if I had 8/1, right, times 3 halves, I could also cross multiply and get, that was 8, 4. So 4 times 3 is 12. Graph. Here's my 0, positive 12. I'll throw in a -12 in there. Is my circle opened or closed? Closed. They're saying x has to be less than or equal to that. So anything to the left of positive 12, including 12, would be a solution. So negative infinity to positive 12. And we'll continue working on interval notation here coming up. All right. So now let's go on to number 7. Put a star by this one for me. New concept, new idea. Anytime you're going to divide by a negative, right? To get the variable by itself, you have to flip the sign. So -3x divided by -3, that's going to give me x. We're going to flip the sign. So x is less than 5. All right. So anytime you're multiplying or dividing by that negative to get the variable by itself, you have to flip the sign. So let's graph. We have 0, we have 5, we have -5. X is less than 5. So here's my 5, right? Circle, is it opened or closed? Open. And since I flipped my sign, it's going to the left. So interval notation for that, negative infinity to 5 in parentheses. We'll talk about verifications here tomorrow. I'm going to have you guys try 8. I'm going to hop in on 9. So again, we want to get x by itself. It's -x/6. So I'm going to multiply both sides by -6. Oh, hey, this one's tricky. Put a star by it. -6 times 3 is -18. I'm multiplied by a negative, so what does that mean I need to do? Yeah, flip it. So we get -18 as less than or equal to x. I guarantee a lot of you are saying, wait, Ms. Widerski, but we have to put the variable first. Right, let's flip it again. So I get x okay, is greater than or equal to negative 18. Ms. Swiderski, I saw that right off the bat. Could I have flipped my fraction to the left-hand side, made my sign a less than or equal to sign, and then put the 3 on the other side, and then flip it again? Absolutely. Okay. As long as you're keeping track of what you're flipping and why, you're good. So now let's go ahead, put a 0. All right, I'm going to put negative 18. I'm going to put positive 18 just to be fancy. And let's graph. So circle, opened or closed? Closed, shaded, right? Anything to the right of negative 18 should make this statement true. So I'm going to plug in negative 18. A double negative would be positive, okay? So negative 18 would be positive 18. 18 divided by 6 is 3. Is 3 greater than or equal to 3? Yes. So interval notation, the lowest it can be, it hits at negative 18, goes on to infinity. All right. I'm going to have you guys try number 10. I'm going to have you guys try 11. And I'm going to hop in on 12 with you. So main ideas on these word problems. Number 1, read and highlight your key information. So it says 6 times a number minus 12 is no more than twice the number. Okay. So 6 times a number. How could I say that? Well, let's say my number's n. So 6 times a number. So 6n minus 12. Well, no more than means no more than also could mean at most, or yeah, at most. That's less than or equal to twice that number. Well, twice that number would be 2n. Let's solve. I subtract 6n, both sides. I get negative 12 is less than or equal to negative 4n. Divide both sides by negative 4. Don't forget, I'm dividing both sides by a negative. What do I have to do to my sign, my inequality sign? Flip it. So I'm left with 3 is greater than or equal to n. Wait, now what? Now I have to flip the sign again. So I get n has to be less than or equal to 3. So it's saying any number less than 3 would make this statement true. Okay, let's try number 13. It says 8 minus 4 times a number is at least 16. Solve for the missing number. Okay, 8 minus 4 times a number, okay, is at least 16. So 8 minus 4 times a number is at least 16, so it has to be greater than or equal to 16. I'm going to have you guys go and solve for the missing number, and we're going to talk about why these word problems work and why my solution would be 3 and whatever the answer down here is. All right, if you have questions, let me know. Main ideas are the word problems, interval notations, and understanding when the circle is opened or closed, along with the signs.